Okay, so far we looked at this problem without assessing probabilities for favorable and unfavorable. We did look at the degree of optimism that we had, but that's not probability. So let's now look at analyzing this problem by assigning probabilities for the states of nature. Okay, first let's populate this table with the financial outcomes. Okay. And let's assign an initial prior probability of 0.5 and 0.5. Okay, we'll do sensitivity analysis with these probabilities in just a second. So now we want to compute expected monetary outcome. Okay, expected monetary value should be expected monetary value, right? And that would be the monetary outcome times the probability. Monetary outcome times the probability. And we need to use some product for that. So that range, comma, that range. Now probability should be absolute referenced. Now some product will match up the numbers cell for cell. Okay, and then multiply the pair and add them up, which is what we want for expected monetary value. And we copy that down. So we have the expected monetary value. And now the decision, I'm going to go to sheet 1 and copy these two formulas. Okay, since the relative positions are all the same, this will work. So if you use 50-50% likelihood of these two possible states of nature, then the maximum expected monetary value is for constructing a small plant. Okay. Now let's suppose we want to do a sensitivity analysis for P. Okay, so at what point, okay, if P goes from 0 to 1, at what point which decision will be favorable or will be beneficial for us? Okay, so let's first set up possible values for P. Okay, so that's P here. So we go from 0, say in increments of 0.1, all right. And let's have one decimal place. So there, all right. Okay. So now there are 3 possible decisions. So let's look at large plant, small plant, and do nothing, right? So I just say it's nothing. All right. So now what we're going to do is do a data table. All right. Okay. So with the P going in there, and we need to make sure that this is set up as 1 minus that. So then only when I insert value P that is different from 0.5, it will automatically change to the complement of that. Okay. So now I want for each of these different P's, what is the expected monetary value to be tabulated here? So I want these 3 to go here. Of course, one way of doing it is to one by one, okay, do that and then do that. Okay, that's small, only 3 possible alternatives. This is okay, so this is probably not a big problem. But then Excel has a nice function that we can use to transpose, and that is an array function. So array function should be entered in a specific way. You have to be very careful. So you want these 3 cells to automatically be displayed in these 3 cells, transposed, right? and you want it to be a formula. You don't want to copy paste transpose, because if you do copy paste, formula will not be pasted. Okay, so there are 3 cells that has to be transposed, so you have to first highlight the range of 3 cells. If you just start with just 1 cell, it won't work. Okay, you have to highlight an entire range that's needed, and then you do transpose. Okay, transpose. Okay, now highlight the source. Okay, now these two should match. You can't have different sizes. All right, now close parenthesis. All right, so now if you press enter, transpose won't work because it is an array function. There is a specific sequence of keys that you have to press and then press enter. So you need to press control and shift, depress it, keep it depressed. So control and shift should be depressed. Okay, and then you press the enter key. Okay, so now you see transpose is entered as an array function. You can see that it is an array function because of the squiggly brackets that you see. So since it's an array function, array functions cannot be altered individually. The way in which you entered, that's the way you can alter it. Suppose if you made any mistake here, you can go and change just 1 cell. Like you can go and change that cell to something, so it's going to give you an error because you cannot change part of an array. So if you made a mistake, then you have to go back and highlight like what you did before, make the change, and then end with control shift enter. So you have to do exactly how originally we set it up. Okay, once that is done, then we can do a data table. So highlight like that. Okay, data what if table. All right, now the p values are in a column, so column input cell, and it should go here. Right, so now we have a list of outcomes, expected monetary values for different p values. Okay, all right, so now let's do some formatting. Okay, it's very important to format. Okay, you want the spread the worksheet to look nice, don't want it to be messy. All right, so let's give it like that. Now we can't we could probably put that p over there and hide this row because we don't want this to be messing up our sheet, right? So there is another way of hiding stuff. So that is, okay, here if you use the same color for font as the background color, so say suppose if you select the same color, then it's gone. So now it looks all right. Okay, the next thing we want to do is to plot these 3 lines. So we can do a line plot or we can do a scatter plot. Let's go ahead and do a scatter plot. Looks like scatter plot is it's a little bit messy, so we need to clean this up. So we have to go to select data and see what the problem is. So it's actually plotting 4 series. We really want this to be x-axis. So let's see what this is. So this is coming from B, so this needs to go. So we need to remove that, right? And then series 2, which is this, we want the name to come from there and the x-axis value should be that, right? Y-axis is y-axis should be from here to there. Okay, series 3. Now series 2, okay, the sheet name should be large plant. Okay, series, the next one, series name is small plant, X values are these, and the Y values are these. Okay, and the next one is do nothing, X values are these, and the Y values are these. Okay, so now let's go ahead and give a name for this. EMV of alternatives. Okay, so we don't need the markers, so let's go ahead and change the chart type to that. Okay. All right, so now you see the maximum value is what we want. So the maximum EMV is that up to that point. Okay, so you can see that point 2 and okay up to here, and then it's the small plant that gives you the maximum EMV. And once you cross this point, then it is the large plant. So the P range turns out to be, okay, so do nothing is less than or equal to 1/6. The probability turns out to be 1/6. You can enter 1/6 here, then you'll see that these two, this is like almost like 0. So these two are same. All right, and then 0.6 is where we have the intersection. So 0.6 actually we can do a points 0.6 1 0.62, yeah, about there, 0.615, I guess, 0.615, yeah, close. So 162.615, you build small plant greater than or equal to 0.615, then you build a large plant.